Hello friends, how are you? Welcome back to the series of lectures on how to handle pyrophoric reagents in organic synthesis. Today I am going to explain about how to handle peroxides. Under this topic we are going to learn about how to handle hydrogen peroxide, benzoyl peroxide and meta-chloroperoxybenzoic acid. Dear friends, these three reagents are highly explosive reagents. Explosive reagents comes under the category of peroxides, and these are pyrophoric reagents. What is meant by pyrophoric? Pyrophoric reagent is a reagent which catches fire upon exposure to heat, light, air, water, right? So in presence of all these things, if a material catches fire, that material or a reagent is known as pyrophoric reagent, right? Under this, the reagents what we are going to learn about is peroxides. Peroxides are, for example, hydrogen peroxide, benzoyl peroxide and meta-chloroperoxybenzoic acid, right? So peroxides, hydrogen peroxide, most of the students think that peroxide, since it is in water and it is commonly used reagent in organic synthesis, it won't harm, it won't catch fire since it is already in water. But be careful friends, be careful while handling this reagent. So why it is used, for what purpose it is used? Yes, it is a strong oxidizing agent. It oxidizes number of functional groups we learn in common reactions or reagents in organic synthesis. So it is a strong oxidizing agent. How it is supplied? It is supplied as about 30% solution in water, 30% H2O2 in water, and another factor is it is supplied in plastic bottle of amber light or black color plastic bottle. Why? Because it is light sensitive. In presence of light it explodes. In presence of light it explodes. Gives rise to what? It explodes and it gives rise to oxygen and heat. Since the explosive reaction are in presence of light, it gives rise to oxygen, and this is a reaction exothermic. Exothermic reaction is a reaction where heat is produced. The produced heat catches fire of this oxygen. Oxygen catches fire with the produced heat. Got it? So the produced heat catches fire of this oxygen. Be careful, don't allow or don't keep or don't expose this reagent to light. So it is supplied in water solution, that is about 30% solution. How to weigh it to use in your reactions? Yes, you can weigh it in a measuring jar, right? So how to quench this reagent? By slow addition of aqueous sodium bisulfite, NaHSO3 solution. What are the don'ts? Don't react with oxidizable compounds like alcohol, acetone and hydrocarbons, because it explodes. So don't react with alcohol or acetone or hydrocarbons because it explodes. Don't expose to light. Just now what I explained, don't expose to light. Always keep it in under dark and cold conditions. Don't shake. So don't shake this bottle or make it friction. The bottle it explodes. If you shake it, the bottle explodes. Be careful, right? So what happens if the reagent is allowed to friction or shake or light? It gives rise to oxygen and heat. That heat and oxygen explodes and catches fire. Dear friends, for example, if you are using this reagent in your reactions, for example here sulfur is oxidized to sulfoxide, disulfoxide, right, SO2. So hydrogen peroxide is used oxidizing this sulfur group. After completion of reaction, After completion of reaction, quenched by aqueous sodium bisulfate reagent. After completion of reaction, quench this reaction mixture by aqueous workup of adding sodium bisulfite NaHSO3 and extracted into your reaction mixture or extracted into organic solvent like dichloromethane. So this is the example taken out from some patent where sulfur was oxidized to SO2. This is how, dear friends, though the reagent looks very common reagent, but be careful while using this reagent. Don't allow it to expose to light because it explodes, and don't shake it or don't make it friction. Always keep cold and store it under dark conditions, right? These are the common factors to handle safely this hydrogen peroxide reagent. The next one is benzoyl peroxide. Benzoyl peroxide is used as an oxidizing agent in various reactions like benzoxylation. There are some reactions, but it is commonly used as a free radical reactions. For example, in these reactions it is used as a free radical reagent where NBS gives rise to this benzylic bromination compound, which is a required compound in these reactions, 3-bromomeconine. When meconine is reacted with this NBS, N-bromosuccinimide, in presence of this benzoyl peroxide only, it gives this 3-bromomeconine. If benzoyl peroxide is not used in these reactions, it gives rise to aromatic unwanted 4-bromomeconine. So this is the reagent commonly used in oxidizing as an oxidizing agent, as well as in reactions where free radical initiation requires. This reagent is used as a free radical initiator or free radical reactions. So how it is supplied? It is supplied about 70% in water. Dear friends, it is always stored in water because it explodes. It is always stored in water. How to weigh it? You can use watch glass like this to weigh it. Then how to quench? Slow addition of aqueous sodium bisulfite solution. So slow addition of aqueous sodium bisulfite solution. Don'ts: it may react violently with alcohol, acetone, and hydrocarbons. Don't allow it to react with these reagents like alcohol or acetone or hydrocarbons. Don't shake or friction the bottle, it explodes. Just now all peroxides explodes if you shake it. If you shake it, explodes. So be careful, right, while handling. Dear friends, it is common reagent, but if you take minimum precautions, it is safe to use. The common precaution is don't shake, don't make it friction. That's it. Always keep it in cold conditions, right? This is how to use benzoyl peroxide. The next reagent in this peroxide reagents is meta-chloroperoxybenzoic acid. Meta-chloroperoxybenzoic acid. Meta-chloroperoxybenzoic acid, mCPBA, commonly known as mCPBA. Meta-chloroperoxybenzoic acid, meta-chloroperoxybenzoic acid. It is used as a strong oxidizing agent. And how it is supplied? It is supplied about 72% in 72% meta-chloroperoxybenzoic acid, and some 10% of meta-chlorobenzoic acid also is added in, and remaining percentage will be water. Dear friends, be careful while using this reagent, right? So you can weigh it on watch glass, no problem. You can weigh it on watch glass. Then how to quench it? Slow addition of aqueous sodium bisulfite solution. What are the don'ts? Don't react with alcohol, acetone, and hydrocarbons because it explodes. Don't shake because it can be detonated by shock or by sparks. So dear friends, be careful. And sometimes since it is supplied in water, sometimes it may require to dry it, make it dry or divide of water, but be careful. There is a procedure, but don't try to dry it. it may explode, and you cannot control, right? And always keep it cold and store it in fridge, right? Don't allow it to dry, and don't shake or because it detonated by shock or by sparks. For example, this is in this reaction, meta-chloroperoxybenzoic acid was used to oxidize this double bond into epoxidation reaction was done by using meta-chloroperoxybenzoic acid, where the reaction was conducted in dichloromethane, and the reaction was completed within 2.5 hours. How to work up? Quench with aqueous sodium bisulfite, add NaHSO3 aqueous solution and treat with aqueous sodium bicarbonate solution. Why it is sodium bicarbonate solution was added? To take out the reagent which turns into meta-chlorobenzoic acid. This benzoic acid will be removed from the reaction mixture by treating with aqueous sodium bicarbonate, right friends? So this is how to use safely meta-chloroperoxybenzoic acid. Dear friends, in this video we have learnt about 3 reagents, that is peroxides, how to use safely. Among them, one is hydrogen peroxide, second one is BPO, benzoyl peroxide, and the third one is meta-chloroperoxybenzoic acid. Dear friends, thank you. So practice safety, always practice safety. These are the highly pyrophoric reagents in organic synthesis, because safety comes first. Your family is waiting for you, your friends, your company where you are working are depend on you. Always practice safe methods. Dear friends, thank you for watching these videos, and please don't forget to click on the subscribe button so that you can get notified about my next videos. Thank you. Bye. Sayonara.